Year 9 higher tier calculator paper. A quick run through of all of the solutions. So, question 1. Starts off fairly straightforward, hopefully. We've got 0.28. If we do it all in pounds, then plain tiles are 28p, 0.28, and I want 450 of them. And then, let's do that with the calculators, calculator paper. 450 times 0.28 equals 126. So we're spending £126 on the plain. And then we've got the patterned, and those are just going to be £9.51, and I want 15 of them. So that's going to be £142.65. £142.65. We're going to add those two together to get your total cost of all of the tiles, so plus 126 onto that, and that's going to give me £268.65. We want to put that in the answer space, so 268.65. Just remember that for your exams. If you don't put it in the space there, you will not get the all of the marks necessarily. Right, question 2. A number of students go on a coach trip. The cost of hiring the coach is £180. The school pays 80% of this cost. The students pay the rest of the cost. Each student pays £1.50. Work out the number of students on the coach trip. Okay, so if the school pays 80% of the cost, you could figure that out, or you could just think, right, 20% of 180 is the amount that the students will pay. So 20% of 180, you can do that with a calculator, or really you could just see 10% is going to be 18, so 20% is going to be £36. So we've got £36, and that's the amount the students are paying. Okay, and each student pays £1.50, so then we can work out the number of students that must be on the trip. So if I do 36 and I divide it by the £1.50 cost, we'll find out how many students must be on the trip. 36 divided by 1.5 is going to give me 24 students. Question 3. I am thinking of two numbers. When I add the numbers, the answer is 1. When I multiply the numbers, the answer is 0.09. What are my numbers? So 1 mark for any two numbers that would add to give 1, or multiply to give 0.09, and 2 marks for the only one which would be correct here, which would be 0.9 and 0.1. Those would add together to give 1, but multiply together to give 0.09. Question 4. It is given that this is 13.488560, round to 3 significant figures, so it's just 13. The third significant figure that's the most significant, second most significant. The third most significant is the tenths column, so it's just going to be 13.5, 1 mark. By rounding each number to one significant figure, estimate this value. So this one to one significant figure will be 10. This one to one significant figure will be 20. And this one to one significant figure will be 40. So I got 10 times by 20, which is 200, divided by 40. You've got a calculator, but 20 divided by 4 is 5. Question 6. Right, we've got some limits of accuracy stuff now. So a car's length is 4.70 meters and a caravan's length is 6.78 meters, both correct to 2 decimal places. Calculate the lower bound of the difference in the lengths of the caravan and the car. So I want to see what the shortest possible difference in their lengths, what the smallest possible difference in their lengths would be. And that would be when this was at its smallest and that was at its biggest, that would make the difference between them as low as possible. So what would be the smallest value that this could take? It would be 6.775. That would be what would round up to 6.78 to three significant figures. And then I would need to take away the maximum possible length of the car. So the maximum possible length of the car, and this is, they've just tried to trick you here. They're both correct to 2 decimal places, so it's not going to be 4.75, it's going to be 4.705. Okay, I'm going to subtract those to find that difference between them. So then you've got a calculator here, so 6.775 take away 4.705 is 2.07. So 1 mark for either of these limits correct, and another mark for this 2.07 meters. Question 7. 3 marks. Right, so I've got A is 42 correct to 2 significant figures, B is 24 correct to, again to 2 significant figures, and C is 14 correct to 2 significant figures. Work out the lower bound for the value of y. So if I want to minimize y, I'm going to minimize y. How am I going to do this? I'm going to need the maximum value on top. So to get a minimum, I'm going to need to have a minimum, and then I'm going to divide it by the most I possibly could. If I start with little, divide it by a lot, my answer will be as low as possible. Now, the minimum for 2a, that means I'm going to need to use the lower bound for a. But for b minus c, to get that as high as possible, I'm going to need to have the, so I need the minimum a. Now, to get this b minus c to be as great a value as possible, b is going to have to be as big as possible, and c is going to have to be as small as possible, right? So if I've got a lot and I take away a little amount, that will give me as much as possible. So, the max, so the lower bound of y, so minimum y, is going to be equal to, right, I'm going to do 2 significant figures. What would be the lower bound here? So it's going to be 41.5. And you get a mark for this 41.5. And then I'm going to divide that by, I need the maximum take away the minimum here. So b minus c. So I want the maximum possible value of b, which would be 24.5. And I want to take away the smallest possible value of c. So that would be 13.5. And another mark for having that all correct. Okay, and then the third mark is going to be for our answer. So we're just going to put that into your calculator. You can use the fractions button. 41.5 over 24.5, take away 13.5. And in my keenness to get on and try to do this rapidly, yeah, it's 2 times by a here. It's just been pointed out to me. Thank you very much. So it's going to be 2 times by 41.5 divided by this 24.5, take away 13.5. So my minimum value of y is going to be, if I just go up here and I do 2 times by this 41.5, take away, divide by 24.5 minus 13.5, that's going to give me 83 elevenths, which when I change that to a decimal is 7.54 recurring. So 7.54 recurring to 2 significant figures is going to be 7.5. It tells me to give that correct to 2 significant figures. That is that correct to 2 significant figures. It actually could not be as low as that, but still, that's what it's asked for in the answer, so we're going to stick with it. Question 8. The distance from Kyoto to Hakata is 638 kilometers. The train journey takes 2 hours and 45 minutes. Work out the average speed in kilometers per hour. So we got speed equals the distance divided by the time. So in this case it's 638. Now we need to be careful. 2 hours and 45 minutes. Do not divide that by 2.45. It's 2 3/4 or 2.75. So we've got 638 divided by 2.75, and your answer is 232 kilometers per hour. That's a fast train. Question 9. We've got expanding brackets, but with surge. So we need, this again is one of the more difficult questions on the paper. So we're going to use, I would use a FOIL method. If you use a grid method, that's fine. I would use a FOIL method. Root 2 times by root 2. Any square root times by itself gives you that number. So it gives me 2. Then, outer, I've got root 2 times by 7. So I've got 7 lots of root 2. Then inner, I've got 4 times by root 2. So I've got then the inner, which is 4 times root 2, which is 4 root 2. And then I've got my last 7 times 4, which is 28. All I need to do is put these ones together. Those are like terms. And also these ones together, because those are also like terms. So then I've got 11 lots of root 2 plus 30. And if you had 30 plus 11 root 2, that would also be fine. 1 mark for any correct expansion here. Next mark for putting it together and simplifying it. Question 10. Calculator skills. Are you able to use your calculator effectively? You should have a calculator like this one. There are newer ones. These ones are now discontinued, but they have the same buttons in the same sort of places. So the key thing is we'd be able to set the situation up. Now this square root goes over everything, so I'm going to start with the square root. Then I've got this division, so I'm going to put that division in with the fraction key. Then I can just write this in as is. So 920 take away 170 times by tan 65 degrees. Now, your calculator will produce the brackets like that. You can put in multiplications if you want, but your calculator should work it out. So it's 170 tan 65. I'm going to take that away. You can put in more brackets if you want to indicate what's going on, but you don't necessarily need to. Then I'm going to divide that by 0. You could work this out individually, or you could put the whole thing in here. 0.012 plus 0.034. It all goes into your calculator. It's just a test of your calculator skills. You press equals. Out comes your answer, 109.8847047, and you need to write down all of the figures on the display. 109.8847047. You need all of that, because it says all the figures on your calculator display. Okay, next question. 11. Oh, we got a little net question. Nice. So, 2 of these diagrams show a net for a square-based pyramid. Write down the letters. So some of them will not work. B will work, so we've got B, but we need both for 1 mark. The other one, which will work, we need to think about the other one a little bit more carefully, how that would work and whether anything is going to work. And the correct one here is going to be E. E also works. The diagram shows Helen's fish tank. The fish tank is the shape of a cuboid. All the dimensions are correct to the nearest centimeter. Helen is going to use a bucket to fill the fish tank completely with water. What's the maximum number of buckets required? The maximum number of buckets required to fill the tank. The maximum number. Okay. So they're all correct to the nearest centimeter. So if it's going to be lots of buckets that you might need to have, then this tank is going to have to be as big as possible. All are correct to the nearest centimeter. So to make this the biggest possible, we're going to have to use the upper limit for each of these lengths. So this one, to get the maximum volume, that one would be 120.5. This one would be 40.5 because it's all correct to the nearest centimeter, and this one would be 70.5. This will give me the largest potential volume. So my maximum volume is going to be, and there'll be 1 mark for this, for generating this correctly. So is 120.5 times by 40.5 times by 70.5, which is 344,000 and 57.625 centimeters cubed. Now, the maximum number of buckets. So 1 litre is equal to 1,000 centimeters cubed. So to work out the number of litres, I'm going to divide by 1,000. So that's going to be equal to 344.057625 litres. And then how many buckets? So there are, Helen's going to use a bucket. There are 14 litres correct to the nearest litre of water in a bucket. So the maximum number of buckets, I'm going to assume that the bucket is going to be as small as possible. This is a very harsh 2 marks, I think. So to the nearest litre, I want the smallest possible bucket, right? If I'm going to maximize the number of buckets that it's going to take, let's take the smallest possible bucket. That will require more buckets to fill it. So I'm going to divide that by the smallest possible size of that bucket. And the smallest possible size of that bucket would be 13.5. And that would then give me my result. So 344.057625 divided by 13.5 is equal to, it's equal to 25.48, etc. buckets. Now, I actually therefore am going to need to have 26 buckets altogether, because the 25th isn't enough. Just been pointed out to me, although you need to actually tip 26 buckets, wouldn't you? On that 20, if the question says give your answer correct to 1 decimal place, which I didn't read, then we're going to need to give that correct to 1 decimal place, so 25.5 to 1 decimal place. If you've written 25.5, you give yourself the mark. If you've written 26, I'm going to allow it as well, because I think the question is, I'm not sure that answer correct to 1 decimal place is correct, so allow both of those answers. Question 13. There are 3/2, or 1.5, which is shown here as 1.5, litres of juice in a jug. Lisa is going to pour juice into some glasses. She will fill each glass with 175 millilitres of juice. What is the greatest number of glasses she can fill? Work out the greatest number of glasses she can fill. So it's just really 1.5, or if I put 1.5 litres, which is the same as 1,500 millilitres, and I divide it by the size of the glasses, 175, that will tell me how much I can fill. So 1,500 divided by 175, that's going to be your, or if you put that as decimal, that is going to give you your 1 mark, which would be 8.57, and so on. And then all I'm going to do is say the greatest number I could actually fill would be 8. That's going to be your 2nd mark. The density of apple juice is 1.05 grams per centimeter cubed. The density of fruit syrup is 1.4 grams per centimeter cubed. The density of carbonated water is 0.99 grams per centimeter cubed. So I've got 25 centimeters cubed of apple juice mixed with 15 centimeters cubed of fruit syrup and 280 centimeters cubed of carbonated water to make a drink of volume 320 centimeters cubed. Work out the density of the drink. Give your answer correct to 2 decimal places. So the density of the whole drink is going to be equal to the total mass divided by my total volume. And in this case, we know what the total volume is. We got that as 320. We just need to work out this total mass. So mass is density times by volume. We've got apple juice with a density of 1.05, and we know the volume of it. So we got the apple as 1.05 times by 25. We've got the fruit syrup at 1.4 times by 15, and we've got the carbonated water at 0.99, and I've got 280 centimeters cubed of that. So I can work out my total mass altogether by just adding those up. So I'm going to do 1.05 times 25, and that gives me 26.25. I'm going to do 1.4 times by 15 for the fruit syrup, and that's going to give me 21. Each of these must be grams, and grams again, and I've got 0.99. I'm going to multiply that by 280, and that's going to give me 277.2 grams. So if I add all those up, we're going to get to our total mass altogether. So I'm going to add 277.2 plus 21 plus 26.25 is equal to 324.45. That's my total mass, 324.45, divided by my total volume, which is 320. That's going to give me the density of the drink. So divide that by 320. I just got that volume from here, and that's going to give me 1.0139 and so on. Keep all your accuracy. Just a sec. So then we've got to 2 decimal places, this is going to be 1.01 grams per centimeter cubed for the whole thing.